So we start with the doctor's orders up here. So 1,200 milligrams per 4 hours. We write it as a fraction like that. So then we'll notice our numerator has milligrams. We want drops in our numerator. So that has to change. Our denominator has hours and we want minutes in our denominator. So that's going to have to change. Yes. I usually change the time first. So I'm going to get rid of the hours. Since it's on bottom, I put it on top. So they'll cancel. 1 hour, 60 minutes. So the hours cancel out. I now have milligrams over minutes. Well, the minutes is what I want on bottom, but I got to get rid of the milligrams. Now, I know you like to multiply each of them out at every step. I usually just chain them all together and do them all at once. So when I get rid of milligrams, I'll put milligrams on bottom. What do I have that equates? If you have 5 milligrams in 2 milliliters, means 5 milligrams is equivalent to 2 milliliters. So 5 milligrams to 2 milliliters. Milligrams cancel out. I now have milliliters in the numerator. Well, that's still not what I want. I want drops. So I got to get rid of milliliters. I put them on bottom. And I have this drop factor. 12 drops per minute is the same, or 12 drops per milliliter is the same as saying 12 drops is equivalent to 1 milliliter. So 1 milliliter is equivalent to 12 drops, like that. So the milliliters have now canceled out. And I do have drops on top, which is what I want, and minutes on bottom, which is what I want. So I have 1,200 times 1 times 2 times 12. That's 28,800, I believe. Drops. Good morning. Then we've got 4 times 60 times 5 on bottom. I believe that's 1,200 minutes. I feel like I've calculated something wrong. Let me double check on my multiplication here. There's 28,000 on. Yep, I'm just making sure. There's 1,200 on bottom. So then we just divide that out. 28,800 divided by 1,200. 24. Okay, for some reason it just didn't feel right. So 24 drops per minute is what we get there. Yep. Okay, he started out with the doctor's orders. 1,200 milliliters, 1,200 milligrams over 4 hours. And we wrote it as a fraction, and then we just started converting. So let's say doctor orders 2,000 milligrams over 5 hours. The label says that we have 25 milligrams and 8 milliliters, a drop factor of 15 drops per milliliter. Have you do the same thing with that? I want it in drops per minute. Just practice questions. Yeah, it's good.
Number 17 from page 178 to 178.
Okay. Ooh, that's a fun one. I'm planning to do something. That's no fair. You guys have figured me out. We'll give her a minute to work on this, then we'll go over that one. Yeah. All right, she's got that problem there.
You're ripping out my hair.
Let's see what you got. Let's see how it works. So we're still rolling. That's good. Okay, so you start out with the 2,000 milligrams over 5 hours. We gotta convert the hours into minutes, so let's do that first. Hours are on bottom, so we're gonna put them on top to cancel them out. 1 hour is 60 minutes. Hours are gone. Now, I need to get rid of the milligrams. I'll put milligrams on bottom. I have milligrams to milliliters there. 25 milligrams is equivalent to 8 milliliters. Milligrams are gone. Well, milliliters is still not what I want. I want drops. So I have to keep going. So I'll put milliliters on bottom. My drop factor of 15 drops is equivalent to 1 milliliter. Milliliters are gone. 2,000 times 1 times 8 times 15. So 240,000, I believe. Yep, 240,000. On bottom, 5 times 60 times 25. Good morning. 7,500 minutes. So divide it out. 32 drops per minute. What's that? Oh, sure. Oh, sure, gotcha. Instead of the 25 over 8, the 25 and 8, 8 over 25, whatever. Oh, sure. For those of you that are just coming in, we're just going over some sample questions and some questions off the homework. So feel free to join in whenever you want, or yell out if you have any questions you want me to go over. This next one is on page 179 in your textbook. Question 17 that's come up. So let's take a look at it. We have an IV bag that contains 1,000 milliliters of solution. Started, bless you. Started at 9 a.m. And this is just questions on the homework is all. It's not any new. So starting at 9 a.m. going to 12 p.m. Good morning. With a rate of flow of 15 drops per minute. At 12, the bag contained 200 milliliters. You want to find the drop factor. The tricky part in this problem is the information you need is hidden. How much time went by here? Careful, from 9 to 12, 3 hours. What's that? Nope. PM is noon. 12 p.m. is noon. Yep. Yeah, midnight's technically 12 a.m. Yeah, so this would be noon here. So it's 3 hours. Next, you have to find the volume of fluid. Well, it went from 1,000 down to 200, so that's 800 milliliters over 3 hours. Technically what has gone down here. So we want to know the drop factor. Well, we have 800 milliliters over 3 hours. We're going to start with that. So we need something, drop factor is always in drops per milliliter. So we need something in milliliters and something in drops. So right now we have milliliters here. So we want to leave that alone. It's on top, that's okay. We can always work with it later. We want to get rid of the hours. Well, this is in minutes. So we've got to convert our hours into minutes first. So we're going to put 1 hour, 60 minutes. So the hours are going to be gone. Now we do have 15 drops per minute. So I'm going to put the minutes on top so that they cancel out. The 15 drops on bottom. So 15 drops is equivalent to 1 minute. So what I have here is 800 milliliters times 1 times 1, that's just 800 milliliters on top. Bottom 3 times 60 times 15 drops. Oops, I got 61 in there. Yeah, it should be just 2,700, right? 2,700 drops. So what that's saying, I mean, we're looking at saying that's upside down. What that's saying is 800 milliliters is equivalent to 2,700 drops. So now we can use that to find our drop factor. Drops, 2,700 drops over milliliters of 800 milliliters. And then just divide that out. Give us the 3.375. Drops per milliliter. It's a pretty viscous fluid. So you'll note here, we didn't have to worry about where we lined up what we started with here. Technically, it would have been easier if we had flipped that over, had 3 hours over 800 milliliters. But at the end, all we have to do is we can pull it apart. This is just saying 800 milliliters is equivalent to 2,700 drops. We can put it back together however we want to. Yes. Yeah, the units tell you where things have to go. If we are going to drops per milliliter, yeah, drops have to be on top and milliliters on bottom, and then divide them out. Yeah. Yeah, what's your question? That's actually was going to be my next comment. That's not a very practical drop factor. Yeah, 3.375 would not be a real drop factor. In the world of math, that can exist. In the real world, it can. In fact, I've never seen a medical drop factor below an 8. I mean, 8 is a very, very viscous, thick fluid. Anything thicker than that would be hard to force through an IV. But yeah, you're right. You don't see a decimal drop factor either. So that is not a very practical drop factor, but it's a mathematical one. And that's probably a very unsatisfying answer. Yeah, I know. Yeah. Yep. The textbook does something called significant digits. Okay. Significant digits is one of those things that if you were an engineer, it would be very, very important to you. At the ground level, it's not quite so important. So that's why the book rounds stuff the way it does. It's not necessarily from an accepted convention. For the rest of this course, I'm just going to say round to 2 decimal places, in other words, the nearest hundredth, unless otherwise stated. So if the problem tells you to round to the nearest drop, round it to the nearest drop. Otherwise, go to the to 2 decimal places. The reason I say that is in the field, in the medical field, the rounding depends on what you have for equipment. Every piece of equipment has a different precision, a different degree of precision. If you're looking at IVs, some infusers you have to round to the nearest drop. Some go to the 10th of a drop, some go to the 100th of a drop. I've never seen one that goes past that. So if we round to 2 decimal places, you can always cut back and round it off further to what your machine says. But unless the problem says to round it differently, go to 2 decimal places for this course. But yeah, in the field, it is your equipment that determines how you're going to round stuff usually. Any other problems out of the homework you guys want me to go over? I do want to start out doing some examples of IV flow rates today, just because we've gone forward, but we haven't had time to go in reverse. Kind of like this example here of finding a drop factor. So I'm going to give you guys an example, let you guys try it, and give you a minute or two to work on it. And then to get you back in thinking in IV flow rates. And then we're going to do some of those reverse examples. So I'm going to give you one to try. Let's say we have a doctor that orders 3,000 milliliters, or 3,000 milligrams of a medication to be administered over 6 hours. Our label is telling us that is constituted at 50 milligrams in 12 milliliters with a drop factor of, let's just do 18 drops per milliliter. Want my answer in drops per minute. So I'll give you guys a minute or so to see what you come up with, and then we'll go through that one. Okay, so we'll start out with the doctor's orders. 3,000 milligrams over 6 hours. First thing I'm going to do is get rid of the hours because we need to get it into minutes. So hours on top, 1 hour is 60 minutes. It really doesn't. I just like to get into a habit and then stick with it. So, yep, it still works. It'll work out, should work out the same. So now we have minutes on bottom, which is what we want. We want drops on top, so we have to get rid of the milligrams. So milligrams are going to go on bottom to get rid of them. We have this equivalency here of 50 milligrams in 12 milliliters. Milligrams are gone, we would now be in milliliters. Finally, we have the drop factor. Milliliters have to go on bottom so they cancel. Well, 18 drops per milliliter means 18 drops in 1 milliliter. Milliliters are gone, we'll multiply this out. 3,000 times 1 times 12 times 18, 648,000 drops. Now, if you wanted to do some cross canceling, maybe cross off some zeros and stuff, you can. I just choose not to unless the numbers get really huge because it's less mistakes usually that way. Down here we have 6 times 60 times 50 minutes. 18,000 minutes. So then we'll just divide it out. I get 36 drops per minute. Any questions there? Yeah. Yeah, the drop factor is the viscosity or the thickness of the liquid that the medication is in. And it literally, if you took an eyedropper and sucked up 1 milliliter of medication, then carefully counted as you dropped it back out, that 1 milliliter would come out of there as 18 drops. GTT is what that is. Yep. So now let's look at some that go the opposite direction. Add a flow rate of 40 drops per minute with a drop factor of 15 drops per milliliter. How long would it take to infuse 240 milliliters of fluid? Well, we haven't done any like this yet, so I'll do this first example, and then I'll give you guys one to try. So here, where we want to start, remember, normally we would start with the doctor's orders, which would be milligrams per unit of time or milliliters per unit of time. So I'm actually going to start with the amount of fluid here, the 240 milliliters. We could start with other items in here and it would work out. And if you want, I can show you that in a little bit. If you know, one example and stick with that. Okay. So here we've got milliliters. What we need is time. So we need to get rid of milliliters. Well, the only thing we have in this problem that has milliliters in it is our drop factor. Milliliters on bottom, so that's going to have to change this to drops. So it's 15 drops per 1 milliliter. So right now what we would have would be drops over nothing, just drops. What this is telling us is how many drops are in that 240 milliliters of fluid. So now we need to get rid of drops and we want to get into time. We do have that flow rate of 40 drops per minute. That means 40 drops equals 1 minute. We have to get rid of drops, so I'm gonna put the drops on bottom here. 40 drops, and 1 minute's gonna go on top. So now the drops cancel out, and we do now have a unit that is in time. So let's go ahead and calculate that. 240 times 15 times 1 minute is 3,600 minutes. On bottom, we've got 1 times 1 times 40, which is just 40. So we take our 3,600 minutes and divide by 40, we get 90 minutes. So it would take 90 minutes to infuse that 240 milliliters of fluid. All of these items here, flow rates, drop factors, anything that's given as a rate, and by rate, I mean the unit is a fraction like that, is an equivalency. 40 drops per minute means 40 drops, or sorry, 40, yeah, is equivalent to 1 minute of flow. 15 drops per milliliter means 15 drops is equivalent to 1 milliliter of fluid. Those are equivalencies and can be used to do dimensional analysis. In other words, make a conversion. Any questions on that? Let's let you guys try one. So at a flow rate of 30 drops per minute and drop factor of 12 drops per milliliter, how long would it take to infuse 500 milliliters of fluid? I'm going to scroll back up after I pause so you can see the work from the last one, just so you can refer back. Yeah, minutes or hours, either one would be acceptable since I didn't specify. Let's see how you did. So again, I'm going to start with the 500 milliliters over 1. Now, milliliters is the only unit we have right now, so we're going to have to get rid of it. Milliliters on bottom. The only equivalency we have with milliliters is that 12 drops equals 1 milliliter. Milliliters are now gone. Don't want drops though, so we're going to put drops on bottom. We have 30 drops in 1 minute. So the drops are gone. 50 times 12 times 1 minute, or sorry, 500 times 12 times 1 minute is 6,000 minutes over 30, which comes out to be what, 200 minutes? 200 minutes if you want to leave it like that. If you change it to 3 hours and 20 minutes, that would be fine as well. Or 3 1/3 hours would be fine as well. The proportion? You could. You would have to do the proportion at least twice to make it work. To do the proportion method, you have to convert. You have to start with something that does not a rate, which would be the 500 milliliters. That would actually go over X. And then on the other side of the proportion, you have to match up something with milliliters. Well, that would be 1 milliliter to 12 drops. And you would cross multiply and divide. 500 milliliters times 12 drops divided by 1 is going to be that 6,000 drops. Then you would take that 6,000 drops, you would go through the conversion again. It's not necessarily harder, it's just a little more tedious is all. Yeah. So then you would use the drops per minute. as your conversion there. Again, you have to line up drops with drops when you do the proportion. You'd cross multiply and divide and you'd get the 200 minutes. How many of you had the 200 minutes or 3 1/3 hours? Divide by 60. Okay. Well, what if we're looking for something else? Like the one question that came up on our homework. At a flow rate of 50 drops per minute, it takes 5 hours to infuse 750 milliliters of fluid. What is the drop factor? So here there are actually quite a few different places you could start. I'm going to go ahead and start with the 750 milliliters, starting with the volume just like we did last time. So 750 milliliters over 1. Now again, even though a drop factor is drops per milliliter, we don't necessarily have to have drops on top and milliliters on bottom when we get done here. We just have to have drops and milliliters in those places. We can flip it around when we're done. So anyway, here we need to get rid of, actually milliliters is okay. So we probably shouldn't be using 750 milliliters, ain't gonna do anything for us, is it? So starting with the 750 milliliters is not going to work for us. Let's start with the 5 hours, see what happens there. So I only wrote these problems like an hour and a half ago. I shouldn't have forgotten how to do them, right? So we're gonna have to get rid of the hours because everything we have here is in minutes. So let's get rid of the hours. 1 hour is 60 minutes. So the hours are gone. Now we have minutes here. We do have drops per minute. 750 milliliters ain't gonna work. So we've tried starting with the milliliters, we've tried starting with the hours, we've ended up going nowhere with either one of them. The reason for that is we're trying to end up with drops per milliliter. We need 2 units in our answer, don't we? Which means we have to start out with something that's 2 units. This is another one, kind of like that problem we did out of the book, that number 17 we did. The information that we need is partially hidden. There actually is a flow rate here other than the 50 drops per minute, and that is 750 milliliters over 5 hours. So here's a problem where we have to put together pieces of information that are given to find the amount that we need to use to calculate. So we have 750 milliliters over 5 hours. So we've combined 2 of those pieces of information to make a rate. From here, hopefully we can get to drops per milliliter. Well, we still want to get rid of the hours. We want to make those into minutes. Hours are on bottom, so we cancel them by putting hours on top. Now we're in milliliters per minute. Do we want to get rid of the milliliters? No, we need milliliters in our answer. We want to get rid of the minutes. So I'm going to put minutes on top, and we do have an equivalency here, 50 drops per minute. So 50 drops is equivalent to 1 minute. So the minutes cancel out. We multiply here on top, it's going to be 750 milliliters times 1 times 1, that's 750 milliliters. On bottom, 5 times 60 times 50 is 15,000 drops. So again, that's upside down from what we really want. We want drops over milliliters, not milliliters over drops. But remember, that's saying that 750 milliliters is equivalent to 1,500 drops. So we can put it back together any way we want to. The 15,000 drops on top, 750 milliliters on bottom, and then divide it out. $20 drops per milliliter. Let me do one more example of that before I have you guys try one. Go ahead. Just to prove to you that sometimes you start with stuff and you can't get where you want to go with it. Trying to show you my thought process a little bit. Hopefully it didn't confuse you much. But yeah. So at a flow rate of 30 drops per minute, it takes 200 minutes to infuse 500 milliliters of fluid. Find the drop factor. So again, we know that we're going to have to combine the amount of fluid and the time it takes to infuse to get a flow rate. So it's 500 milliliters over 200 minutes. Milliliters I'm going to keep, minutes I'm going to have to get rid of. So put minutes on top. We actually have 30 drops in 1 minute. The minutes cancel out. We do now have milliliters and drops, which is what we want. So on top, we have 500 times 1 is 500 milliliters. On bottom, 200 times 30 drops. That's 6,000 drops. So we can take it apart and put it back together. It'd be 6,000 drops over 500 milliliters. Giving us 12 drops per milliliter. Any questions there? All right, let's have you guys try one in your notes. Got a flow rate of 40 drops per minute. It takes 2.5 hours to infuse 400 milliliters of fluid. Find the drop factor. I'll give you guys a couple minutes. Okay, so where do we start? Yeah, 2.5 hours. And the first thing we're going to do is change it to minutes. 1 hour, 60 minutes. If you just put in 150 minutes, that's wonderful. Now, yes. Yeah, because if I punch in the calculator, I'm punching in 2.5 anyway. Put milliliters on bottom. Oops, I don't need to get rid of milliliters, I need to get rid of minutes. Put minutes on top to get rid of them. And drops on bottom, 40 drops in 1 minute. Minutes are gone. On top, we have 400 milliliters. On bottom, 2.5 times 60 is our 150 times 40. It's 6,000 drops divided by 400. To give us 15 drops per milliliter. Any questions there? Yep. Yes. That would always come out right if you just put in the minutes instead of the hours. Yeah. Okay. At a flow rate of 45 drops per minute and a drop factor of 15 drops per milliliter, how much fluid would be infused in 3 hours? So I'm asking for how much fluid, which means what would the units of my answer be? Just milliliters. Now note, this is just a single unit, milliliters. If I look up here, this one was a compound unit that I wanted in my answers. It was a rate, drops per milliliter. Since this was a rate, I had to start out with 2 units here in my first number that I started with. I had to start out with a rate in order to end up with a rate. Down here, I'm ending up with a single unit. What do you think that means with what I'm going to start out with? I have to start out with a single unit. So the only thing in this problem that's a single unit is 3 hours. Very good. Now I need to get rid of hours. I don't have anything in the problem that relates hours. I have minutes, so I'm going to have to change my hours into minutes. Now I'm going to get rid of the minutes. It's the only units I have, so I'm going to get rid of them. I have my 45 drops per minute. So 45 drops in 1 minute. Minutes are now gone. Now I'm going to bring in my drop factor. The 15 drops go on bottom to cancel out the drops for 1 milliliter. And here I see I've got 3 times 60 times 45 is 8,100 milliliters on top. On bottom, 1 times 1 times 1 times 15. I divide that out. 8,100 divided by 15. That's 540 milliliters of fluid that would infuse in 3 hours. Well, it could be 540 milliliters in 3 hours if we asked for a flow rate, but we just asked for how much. We were asking for a volume. So a volume is just that single unit of milliliters. This is one for you to try. At a flow rate of 60 drops per minute and drop factor of 12 drops per milliliter, how much fluid will infuse in 40 minutes. I'll give you a minute. So we'll start with our 40 minutes. Now it's already in minutes, so we don't have to make that time conversion. We're gonna put minutes on bottom, drops on top, 60 drops is 1 minute. That was the only unit that had minutes in it, so we had to use that to make that conversion. Now we're gonna get rid of the drops. Drops are gonna go on bottom so they cancel out. We have 12 drops in 1 milliliter. So drops are gone, so we've got 40 times 60 is 2,400 times 1 milliliter is 2,400 milliliters. On bottom, we've got just the 12. So that divides out to be 200 milliliters of fluid. What's that? Okay. Oh, sure. That's a little small. Now, since we've only got 5 minutes left in the first hour, let's do a couple more review problems from the last couple of weeks. So, doctor orders 0.1 gram PO. Our label says it is GRSS per ml. Find how many milliliters to administer to the patient. There's a little bit of terminology and abbreviations in here to dig through. Remember, you always start with the doctor's order. This is 0.1 gram over 1. What would we do with it from there? GR is not grams, it is grains. What's GRSS mean? There we go. SS is half. So GRSS is 1/2 grain. Per milliliter means 1/2 grain equals 1 milliliter. Now, since our concentration is given as 1/2 grain per milliliter, we have to start by converting the doctor's orders from grams to grains. And put grams on bottom, grains on top. What's the relationship between grams and grains? 1 gram is how many grains? 18? 15. That sounds better. 15 grains in 1 gram. So that cancels out the grams. Yep, that is in your book. It's on that conversion page. What's that? Page 115. Thank you. So now we have to get rid of our grams to convert into milliliters, or grains, I should say, to convert into milliliters. We have 1/2 grain equals 1 milliliter. So now what we have here when we multiply this out, 0.1 times 15 grains, grains cancel, 0.1 times 15 times 1 milliliter is 1.5 milliliters, over 1 times 1 times 1/2 is 1/2. So then we just have to divide out. 1.5 milliliters divided by 1/2 is 3 milliliters. So you would administer 3 milliliters to that patient. So you can see throwing in the grains, you may have to go look up a conversion, but it doesn't change the calculation at all. So let's say we have a doctor's orders for 600 milligrams of Motrin to be given orally. The label is GRX tablets. What do we start with? Always start with the doctor's orders. 600 milligrams. Once again, our label is in grains. GRX tablets. GRX means 10 grains equals 1 tablet. So before we can convert to tablets, we have to convert our milligrams into grains. 1 grain is 60 milligrams. Now I'll warn you, I think I mentioned it when we talked about this a little bit. 1 grain equals 60 milligrams is approximate. Technically, it's like 62 point some milligrams. In many cases, they do round it off to 60 to make it easier, but it is, some textbooks might ask you to do 62 or 62 point, whatever it comes out to be. So that has us in grains. Now we're going to go from grains to tablets. So grains will be on bottom. 10 grains is 1 tablet. So the grains are gone. 600 times 1 times 1 tablet is 600 tablets. On bottom, 60 times 10 is 600. That divides out to be 1 tablet. Any questions? That's just the Roman numeral 10, yes. Okay, it is the end of our first hour, so let's go ahead and take a break.